Hey, with around 180 manufacturing plants and business presence in over 150 countries, Bridgestone is the largest tyre manufacturer in the world. Today on LokadTV, I'm delighted to say we're once again joined by Nicolas Vandeput, who's going to help us take a peek behind the scenes at Bridgestone and understand the daily operations of a large multinational corporation. So Nicolas, thanks very much for joining us again on LokadTV. So I think a nice place to start is we're going to be talking a bit about the project between Lokad and Bridgestone. A nice place to start would be if you could just sort of illustrate kind of the scale of the project. So how many SKUs, how many different locations are we talking about here?
Yeah, so it's really a huge project because we have at Bridgestone Europe around 8 manufacturing plants, around, in top of that, 20 warehouses in Europe, which is in total 40 to 60,000 different SKUs that we have to manage automatically every single month, 6 months ahead. So yes, it's really huge.
And Johannes, we're talking about a multitude of locations, going all the way from sort of Latvia all the way to Portugal. So what does the complications of having so many different locations kind of introduce?
And it's the crux of the problem is that when you have such a complex network is how do you actually solve the problem? Because when you typically tend to tweak your network, you don't solve the problem, you just displace the problem. So yes, you solve an inventory issue in this country, but you just created another inventory issue somewhere else, or etc. So basically not shuffling around the problems, but actually solving things, I would say, from a holistic perspective, so that's kind of network-wide perspective. That's a real challenge, and that's very, very difficult. And then in Europe, which is both unified in terms of economic markets, but also very fragmented because it's different countries, different languages, different seasonality. You have tons of things that really complicates that complicates the challenge. Plus, everything is more complicated when you operate at the scale of Bridgestone.
Okay, so I think it'd be useful for our customers to kind of introduce a bit about the initial scope of the project. So what was the initial idea behind the project? How did it all sort of start out?
So initially, a couple of years ago, we had a supply chain at Bridgestone managed by very different teams. In every single country, we had a different team managing differently their own supply chain, and that resulted in a lot of issue, because even if you reach the local optimum, which you don't necessarily reach, you don't get the global optimum. You even had some wars in between country. You know, when you know that there's going to be a shortage on a specific item, what do you want to do? You want to order it for yourself, and then you just create the shortage, and then everyone's fighting. And then people think like, hey, I know this guy is going to make a big order, so I'm going to do the big order first now. And then you get a lot of shortage wars, right? So that was the scene at the beginning of the project. We had different teams with different level of maturity fighting. And then we said, okay, now we want to have a unified model, run from one single location that will put everyone at the same level of using the stock targets.
Okay, so let's talk a bit about that unified model. Johannes, what was so different about the approach that Lokad was kind of taking to this problem?
I mean, the perspective is to say we are going to conceptually run and execute the entire network. So it's not about thinking one location and we optimize. No, we think the whole multi-echelon, that's a technical term, supply network where we have different stages on which the goods, which are tires, are actually flowing from basically production to end consumers, that are the various channels that where Bridgestone actually distributes its products. And when you want to consider this network, you have to think of all the streams of products and exactly what is the demand. And here, that's a trick, is that most at every single stage, except I would say the end consumers, it's basically things that you generate yourself. You see, so you have to be very careful not to mix what is actual demand with what is actual. I would say the actual noise of your own process that just generate orders inside the network. So that's our approach, was to have like a complete modelization of this network, complete modelization of flows, which is easier said than done, by the way, and to align that with the end game, which is ultimately serving the as best as possible the channels themselves, which is tricky because again the mistake is to focus on what is happening in the middle of the network, which is in a way kind of completely irrelevant. For example, from an end client perspective,
which we call the bus at Bridgestone.
Ah yeah, the bus.
The bus, from the bus perspective.
The bus perspective, it doesn't matter if half of the intermediate layers in the multi-echelon supply chain are out of stocks, as long as when you do request your tires, they are there for you. You know, so that's the trick. Is that's what matters is the perspective of the bus. What is in the middle is not inconsequential. It is very important, but it's only a mean to an end. This is not the end, and that's where it gets very tricky, both from I would say a data processing perspective, but even from a pure mathematical perspective.
Okay, and the way I like to think about sort of a multi-echelon problem is there's lots of different layers and lots of different tiers. So what are the key sort of difficulties that this kind of introduces?
Just the sheer combinatorial problem, the sheer number of possibilities. You know, it's as soon as you have many locations you want to. So first, we are talking of tens of thousands of SKUs, but you have to think that every single decision done on pretty much every single SKU can potentially impact all the others. So it's kind of fundamentally, unless you use smart algorithms to make it faster, but fundamentally it's a very quadratic kind of problem where whenever you look at a SKU, it can have an impact on any other SKU. And so you have like 60,000 SKUs times 60,000 SKUs if you want to investigate, to probe the ramification of every single change that you're doing. But it's even worse than that because it's kind of time driven. So if you touch a SKU, it will have consequence over time over all the other SKUs. So you end up, for every single SKU, I can modify something, and then it will impact all the other SKUs. So already it's every single time I touch a SKU, a lot of other things to visit. But worse than that, it's I will have to visit all the other SKUs for up to 6 months ahead,
Yep.
You know, playing it day by day to see how it happens. Obviously, we are doing things that are a bit smarter than that because that would be way too.
And something that's important for us was the seasonality approach. The fact that for tire business, as for many business, well, you have a seasonality, you have summer tires, winter tires, and you have to know that at some point the season will end or another season will start. So it was really important for us not just to focus on one single month, like know what's going to happen next month. No, we also want to know, okay, but what should we have in 2 months time, 3 months, 4 months, and so on. And when you put inventory at a certain place, you have to know that, well, next month might be totally different. So maybe you can get a bit more of stock because that's fine, the season's growing, or maybe you need a bit less of stock because that's the end of the season, right? So it's really a difficult problem, especially as soon as you start to look at 6 months ahead.
And so let's talk about sort of the change management process now. When you're coming to the powers that be and you're sort of explaining that you've got this new approach, you want to take it all under one company and take one singular approach. How did you sort of, knowing the inherent complexity behind it, how did you sort of approach that change, and were people really interested in it?
So change management is extremely difficult. That's for sure. It's one of the main challenges. So as we just discussed, the model is extremely difficult to do. Like the math is really complex, and then you get to convince people to follow you and to use these new stock targets of the model, and this is really difficult. So what we did is we started with a smaller scope on just a specific subset of tires, and we created that for some months. We tested it and we proved our case that it did work. And once people started to understand that, hey, it works for these, maybe we can grow to something else, and we can grow to the whole Bridgestone company. On the side, I also spent a big amount of time to train people, meaning we did training and again, and we communicate the maximum with people, and we also shown many examples of totally counterintuitive things. People were assuming that a stock, the right stock to have would be like, 1,000 tires, but actually 200 would be enough, right? And if you come to someone and you tell them, look, I know that you want to have 1,000, but 200 is enough, people will be, okay, you're totally crazy. I will never accept 200, it's 1,000. And then you really have to go, really showing the number, the graph, the sales, the forecasting. But you see, if you had 200, your service level would already be at 99%. You don't need this 1,000. And you really need to show the graph, the numbers, and so on, over and over again until the people agree that, well, it will work with 200s. Yeah.
And did you want to dive in a bit there?
Yeah, I mean, I completely agree with the counterintuitive effect. I mean, it's especially when you say, I'm going to reduce the stock, what you're doing is this is multi-echelon, multi-echelons. So that means that you are actually liberating more stock for the rest of the network, including your own internal supplier. So if you say I'm keeping less stock, it typically means that whatever comes before you might actually keep more.
Yep.
And so if you do run out, then you have a much higher probability of being able to replenish yourself.
Mm-hmm.
And the same is going to be true for every other locations because
Yep.
they are well behaved.
And that's exactly one of the issues we had at Bridgestone. So before we started the project, before I came, the main belief was to say that we need to have all the stock at maximum in the market, so close to the customer or the bus as we call it. So you need to have all the stock close to the bus. And as soon as you start to run these multi-echelon optimization, you realize that actually that's not true. You need to have the stock or a bigger part of the stock at the manufacturing plants, for example, which is far away from the client. But as Jeanette just explained, if you have one market that needs some extra tires, they still have the tires available in the manufacturing plants for them. So that was much better. But it's really difficult when you launch this project and when you had the belief for nearly a decade that the stock needs to be close to the market and you come and you say, you know what, the stock shouldn't be there. That's where change management comes in, yeah.
Okay, so we sort of touched upon change management. The project actually went live back in March 2018. So as well as the problems with change management, what about sort of the technical challenges we sort of had to come over? What were the initial challenges we faced?
I mean, first we have to plug a probabilistic vision of a multi-echelon network. So that's a that makes things very complicated. So probabilistic means that the future is uncertain, not only in demand but also lead times, and even future and even to some extent the actual stock quantities at any point of time in the network, which is also an uncertainty. So it's I would say this quantitative supply chain approach all over again, but with an intensity that was, at least for us, a bit unprecedented in terms of just the sheer amount of stuff that is uncertain that need to be properly accounted for.
That's why we need you.
And but the trick is that erraticity or the fact that there are probabilities doesn't mean that you don't know anything. I mean, especially the consumption patterns in terms from the bus perspective, it's not that erratic. I mean, there is like entire fleets of vehicles that are driving in ways that are very predictable and very steady. So that's why overall the business of Bridgestone is not behaving like that. I mean, it's something that is still very behaving, I would say, very smoothly overall. Because in the end, it's vehicles that needs repeatedly new tires. But the interesting thing is that this steady overall demand consumptions generates enormous amount of noise in the multi-echelon network, and this can be actually accounted for with probabilities, and that's what we did.
And that's one of the main reasons why we chose Lokad, was the fact that the other software on the market that can also do multi-echelons, they are all into a lot of very strict assumptions, saying, for example, all the demand below follows a normal probability curve, all the lead time follows a normal probability curve. Once you looked at not just the demand, but the demand, the forecast, the lead time, and so on, you realize that maybe normality is not like the main thing at Bridgestone. We need something much more accurate, much more, I would say, tailor-made just for us. And this is really where Lokad is shining by the ability to really define SKU by SKU probability function. And this is really why we have chosen Lokad to deal with.
Okay, so how did you actually take that sort of noise and translate it into kind of a probabilistic forecast? What was kind of the approach you took there?
I mean, we have a whole algebra of probabilities at Lokad that is, that's basically the basic bolts and that you have with Envision. But at a more fundamental level, I think what what was really a key differentiator was the programmatic approach that we had. So it might be a bit surprising, but when Lokad we start a project, we start from programmatically from a blank sheet. From a technological perspective, it's not the case. We have already many building blocks that are available out of the shelf. But we do not come to a company like Bridgestone with a template and say, and we try to fit whatever is Bridgestone multi-echelon network, which is just the DNA of Bridgestone. It has no chance whatsoever that we will have something that actually fit that. So we do it the other way around. We have at Lokad, we have this programmatic approach where we say, we start from a blank sheet, but we have a programmatic environment that is very, very highly productive, that is very expressive as long as we are dealing with supply chain problems. So we can't do image recognitions, it's not the purpose. So it's very focused on supply chain. And that let us, I would say, craft something that really, really fit the problem as much as we understand it, which is also something that is part in flux.
Yeah, so if I may add something here, and what you said is really true for us. So if you go on the market, and we've been discussing with softwares, trying some, the issue is that they come with a solution and you have to fit your problem to the solution, right? They come with a set of assumptions like, okay, demand should behave like that, forecast should behave like that, lead time should go this way. And if you just cannot fit your network and your supply chain to that, you at some point you are losing focus, right? And that was really an issue for us, because when you think about it, a supply chain like Bridgestone, it's unique. Like any other supply chain, like big ones, they are all unique in different ways. And this is really why we needed to have Lokad to really start, as you said, from a blank page, saying, okay, we have different algorithms, we have different models, let's see which one we can use and how we can construct a solution together.
So let's talk a bit about the results of the actual projects now. So how did the project actually get implemented, and what were the initial sort of results we saw, and what do we have to change and adapt as the project sort of went on?
So Lokad, we are pretty much focused on decisions. You know, so I mean, a key idea is that when we do this sort of project, the goal is not to have like percentages or reports. It's to output things that are I would say decision-like in nature, so something that has a physical impact on the supply chain. So here we are talking of the, correct me if I'm wrong, but the replenishment policies of every single SKU over the network. So that's the output, that's the numerical parameters that govern those replenishment policies. And one of the reasons is that there is already systems in place to actually execute those replenishments. So Lokad is just an analytical layer. We are not a replacement for the ERP, WMS, MRPs that Bridgestones are using. So we are just focused on the parameterization of the replenishment policy. So that's the output. But now what is changing, I would say ongoing, is the way we reflect the economic drivers, the overall goals, how we define, you know, whenever you want to optimize, you have to define what is your target, and this is something that is, I believe, that was evolving very rapidly at the beginning, and now that is evolving much more slowly. But it's still evolving, and I suspect as Bridgestone undergo further transformations, it will basically be forever evolving, at least at some pace. So that's I would say the project as it stands right now. But we are now generating, I would say, with a daily pipeline the results. Although probably Bridgestone, considering the schedule, you're probably not using those results on a daily basis. It's probably weekly, once a month, because there is the entire network to retune to the new strategy.
Yep.
So from your perspective, what sort of evolution have you seen over the course of the project?
So the first thing is that Bridgestone is so big, as many of the supply chain, it's like a living organism. It changes every single month. Every single month you have people asking to change some parameter, to close a warehouse, open a new one, change the route of tires, change how some clients behave, how we have to deal with specific flows and so on. So when we started the project, something that was extremely important to me was the idea that it needs to stay really agile. So we have some mathematical foundation which won't change, But on top of that, we have another layer, and it's a layer open for discussion with the local planners that come back with feedback saying, okay, you know what, maybe as of next month, I want to have this flow going that way and so on. So we have to be able at any point of time to really update all these roads, but also update some smaller part of the logic and so on. And that was extremely important to me, but that's also extremely important for all the team at Bridgestone to have the idea that, okay, this is not rigid. It's not like a software you install, you have some army of consultants that comes in one day, install it, and you just pray that nothing will ever change. No, we have the ability month after month to tweak it, make it change. And today I cannot tell you how it's going to be like in 6 months, because if I knew already, I would have done it already, right? I'm just waiting for feedback from people coming back to me saying, okay, we can fine tune this a bit further.
Okay, and what about sort of the impact of the project? Has it had any impact upon like IT infrastructure and any changes that are actually been made to daily operations at Bridgestone?
So the impact on IT, I'm quite happy to say it's none. The idea, as Johannes said, is not to replace ERP, it's not to replace MRP, not at all. The idea is really to use Lokad, to use these stock targets as really like, it's just the output are just these stock targets that we then feed to the other system. It was really used Lokad as an outside machine, extremely smart, that populates these targets, but we still keep the IT as it is. And I'm extremely happy that we are able to do that. Why? Because it allows us to move fast, basically. We don't need to go through a whole IT procedure and so on. It's just online, and this works really fast, and we can deploy that extremely fast, and it's really great for us at Bridgestone. When you think about it, the implementation time of this project has been extremely short, thanks to many different factors, one of them being the fact that we don't need IT infrastructure from Bridgestone.
Okay, great. And Johannes, what about the impact at Lokad? What have we learned from implementing such a large multi-echelon project such as this one?
I mean, first we learned that it was possible. It's great. I mean, we were very confident in our capability to execute that, but still, it's never a given. And that's, by the way, one of the reasons why you have to move fast, because you want to fail fast if by any chance it would not work out. You don't want to spend 3 years on a project to realize that technology isn't ready yet, it's just not working. But also the fact that I believe that we have this, that quantitative supply chain is also a game-changing thing from, I would say, more traditional manufacturers. I mean, traditional not in the sense that it's, Bridgestone is top of their game in terms of technology for the tires. You know, it's just that any companies that has been around for decades had needed to have processes in place for a long time, and it's interesting to see that those processes can be successfully upgraded. And the way I see that is that we can, I would say, free a lot of time on many local teams to focus on things that matter more than, I would say, crunching Excel sheets. Because you see, if you take the ancient world where you have many countries, many locations, each one, I would say, each one fighting for their own stock allocation.
Yeah, which was the case.
And it's not that they are. I would say, it's just that it's not that they are badly trained or etc. It's like the by design consequence of the process. If you set up your process with literally replenishment teams that compete with one another, then guess what? They will compete, and that gives all those kind of competitive behaviors that degrade the performance of your supply chain as a whole. And it's not that they are badly trained, it's just that it's by design. So here, I believe that one of the success factor of this project is to think that all those teams will have a lot more time to focus on problems that they can actually solve, and that will not conflict, and them solving those problems will be like a win-win with the rest of the company, instead of having like
to fight from one market
I win,
to another.
but then you lose, and the next round you win, I lose extra. You see, that's something that is much more capitalistic for Bridgestone as a whole.
Okay, Nicolas, I'll leave the sort of concluding comments to you. What are your key takeaways from this project, and what are the key results that you'll really take back from this?
For and foremost, I'm extremely happy that we could achieve that together with the team, and I'm talking about two different teams. First, Lokad. This has been like a mathematical challenge, a data challenge with Lokad, but that also this has been a challenge with the team at Bridgestone, and this is something that has been extremely important to me in this project. And I said it's still ongoing. It's the fact that we could get feedback from the local team, the local planners, to help us out to design the best model possible. So it has been really done hand in hand with the local team. So it's something really bringing all these people that have been used to fight for stock all together to design the best model, right? And this is to me a real success. And I hope that I'll be able to do that with Lokad at other companies.
Right. Okay, we're going to have to wrap it up there, but thanks very much for your time this morning.
Thanks.
So that's everything for this week. We'll be back again next week with another episode. But until then, thanks very much for watching.